Thank you for talking.
Yeah, sure. Okay, so in LabVIEW, we are going to go over the environment of the LabVIEW. We are going to look at the basic functionality, how to create a mathematical equation and solve them. And we are going to be looking at formula evaluations. So I know what we are doing. Let's go ahead and open the software. Actually, let me go ahead and share my whole screen. Now everything will be recorded. So LabVIEW is right here. So we had 2023 Q1. That was the last one that we purchased, the first full software, and we still have it. We still have the license, so we are using it. Since the LabVIEW, we are just using for 3-4 weeks, and we don't use that much. So we decided not to renew the license. It's pretty expensive, and the new version is pretty similar to the last version. National Instrument just does this thing that every year they release a new version, and although it's the same version, but Multisim and LabVIEW both are National Instrument. You guys must be using Multisim as well. With Multisim, we do purchase the new version because if you create a program in the older version, it does not. If you create the program in the newer version, it does not run in the older version. Now, LabVIEW by default, if you create a program in a newer version and you save it in a newer version, then you cannot open it in an older version. However, in LabVIEW, you do have the option to save the program as in an older version as well, which Multisim does not give you that option. So Multisim, we have to renew the license every year. LabVIEW, we decided we don't really have to do that because we can just give this to students and they will save it. And even if the students somehow they are using a newer version, they can always save the program for the older version, 2023 Q1, and I can still open those programs. So the first screen that's going to show up when you start it is going to be something like this. You will see some programs over here from last semester. You won't have those files, of course. I opened those files. That's why you can see these files. But for you, it's going to be just blank under Open Existing and Create Project. So what you're going to do, you're going to create a project. And under project, you have different options available. And you're going to use blank VI. Blank VI. VI is the extension of LabVIEW files. VI stands for Virtual Instrument. So all the LabVIEW files, when you save them, they will be saved as .vi files. And those are the files that you are going to be submitting for your homework and for your exam. You're not going to be taking a screenshot or anything, but you're going to be submitting your actual original files. And then I will be running those files in LabVIEW to see if your program is correct or incorrect, or what mistakes did you make, if any. So you're going to be creating blank VI files. So choose blank VI, finish, and it is going to open 2 windows. And if you are working with me, then of course you can see those windows. If you cannot work with me because if you don't have the software, then don't worry about it. Let me close these windows. Close this. Notes as well, because I don't really need it. Okay. So you have 2 windows. One window is the front panel right here. And of course, one window is the block diagram. And the 2 windows are different from each other from the background color and everything, as you can see. If you are working with LabVIEW right now, it's possible that a palette also opened up when you go to the front panel and when you go to the block diagram. Right now, you don't see any other window on my screen, though. Front panel is the window in which you are going to be creating your system. LabVIEW is a graphical programming software. It's a software where you can create your systems graphically, and you can present those systems in front of an audience. So if you are an engineer, you're a control engineer or any type of engineer, and you are creating a control systems, and you want to present that system in front of an audience, and you want to show the functionality of that system, that you flip this switch, this thing is going to happen, Universal Disney ride is going to start moving, or if you do this thing, you push this button, this thing is going to happen. Or if you're importing data, then you can play with that data in LabVIEW and then generate graphs and all those. Like, this is interactive software. So you can do things on the fly. You can create system on the fly. You can change parameters on the fly to see how the output is going to change for the system and all those things. So pretty interesting software, very useful software. So your system that you're creating, that the one that you have to present or you want to present in front of an audience, that system is going to go in the front panel. So that's your front. That's why it is front panel. The functionality of the system, the logic of the system as how the system should work, that logic is going to be designed in the block diagram. So that's the purpose of these two windows. Front panel is to represent your system, block diagram is to create the logic to run that system that is in the front panel. Now, when you save this program, so when you're creating something and you go, and there are two options available, save and save as. So if you are using the same version, 2023 Q1, then you just have to hit save. It's going to save in this version. If you're using a newer version, some reason you find a newer version, or I don't know, you can download it from National Instrument, but I don't know how long is the free evaluation period for that. And that's why we are just giving you this copy, that you can just install this copy. But in case if you do install a newer version, then you can do save as, or save for the previous version, save for the previous version option. And under that, it's going to give you option to save for previous versions. So if you're using a newer version, make sure you save it as 23.1, 23 Q1, so 23.1. For me, since I'm using 2023 Q1, the last version is 22.3, and then 21, 20, whatever version. But right now I'm using 23. For you, if you install this, the one that we are giving you, you just have to hit save. And if you hit save, it's going to save both the front panel as well as the block diagram. You don't have to save separately in each window. Now, how you create a system? How do you create a system? Now, the system is created using the libraries or using the component that are in the libraries that is associated with the front panel. Right now, you don't see any library. Most likely, when you open it, it will open up. But if it doesn't open up, then go to View, and front panel library is called Controls Palette. So hit Controls Palette. And then this palette is going to open up right here. So it has different folders or different libraries. And under each library, you have sub-libraries. And under each sub-libraries, you have different components available. So for example, modern, few system design, silver system, and there are multiple libraries that you can add. But we are just using it for 3 weeks just to give you a flavor of this in case if you have to use it. I only use it one more time in control systems, because again, the software is intended to be used in control systems. So I use it in control systems as well. But other than that, we don't really use it much in the program. PSpice is used very frequently in the program, and MATLAB is used very frequently, the third software that we are going to study. But this software is used here and in control systems. So Express library is a library that you used very frequently. All the important functions are basically collected in the Express library. Likewise, modern library, a lot of functions in the modern library that you use. Other than these two, I don't think we use. Sometimes students use stuff from Silver library, but generally all these are present in the modern library as well. So modern and Express, I believe these are the two most important libraries that you will be using, and pretty much all the functions that you will be using to create your systems will be present in Express and Modern library. Now, if you don't know where some function that you are looking for is present, then you can always search for that. For example, if you don't know where LED is located, then you can just do LED, and then it's gonna show you round LED is LEDs, round LED booleans, LED button, and you can click on any one of them, and it's gonna take you to that specific folder and subfolder where LED is located. So if you know what component you're looking for, if you just start typing, it's going to show you a list of libraries where that component is located, and then you can find that. So search is very helpful, especially if you don't know component where you can find it. But as I said, Express library and Modern library, these two will have most of the components that you're looking for. Now, the palette that is associated with the block diagram, that's called, again, go to view, that's called functions palette, because you are creating functionality between the components that you're putting in the front panel. So once you click on functions palette, then a function palette is going to appear. Now, again, I think I closed these palettes. That's why they were not appearing when I run the program. But in general, they appear when you go to one window or the other window, then control palette and function palette appear by themselves. But if you close them, you can always go to view and then open them as I showed you. Function palette, they have all the blocks that are used to create functionality for your control systems, as you will see. Programming is an important library that you will be using. Mathematics you may be using. Of course, Express you will be using. So 3 libraries that you will be using frequently are Express, Mathematics, and Programming in the functions palette. Rest of them we are not using, at least in this class. So all of your functionality that you will need, they should be present either in Express, Mathematics, or Programming, or sometime it is present both in Mathematics and Express. So you can choose whichever way, whichever one that you need. Anytime you put a block in the front panel for your system, an equivalent block is going to appear in the block diagram, because you will have to create the logic between the blocks that you're putting in the front panel. So there has to be an equivalent block in the block diagram for that. And then, of course, you're going to connect those blocks in the block diagram, and you're going to create logic between them by using different components. And once everything is connected, then you can execute your program using this run button. If you put run button, and run button is in both. So here you're going to see the result. So if you press run button, it's going to run it only once and show you the result. Many times you want to run it continuously, so you can, if you're changing the parameters of the system to see how the output is changing or anything, then you can also run it continuously. The second button is run continuously. The third button is a stop if you want to stop it if it is running, and the fourth button is to pause the execution and then execute it again by unpausing it. So these are very simple. That's a very simple interface, or very simple system basically that you have here. You have some menu, basically file, of course, and edit. You can do component. You cannot edit component, but you can have a lot of things that you can do from here. Generally, we don't really use that much. View, as I said, control palette, tool palette, everything is in view. And then there are other menu items that some of them we will be using and some of them we don't really have to use. So once we use something, then of course you will see. There's also a third palette, which is, if you go, you have a tools palette right here. Now, if you click on tools palette, this is what you will see right here. Tools palette is basically a collection of different functions that your mouse can assume. Right now, this is green, and it is in the automatic tool selection mode, which is by default. And my advice will be, don't even touch that. Don't even go to the tools palette, because in automatic tool selection mode, Your mouse can change into a wiring tool. This is a wiring tool, but your mouse can change into a wiring tool as soon as you will bring your mouse to the node where you have to start wiring, as you will see when I do the programming. Likewise, if you have to type something, then you can just double click your mouse and it's going to convert into typing tool, edit text. So by default, it is in the automatic tool selection, and that works perfectly. You don't have to disable it. As long as it is green, that means it is enabled. If it is gray, that means it is disabled. So just keep it green and don't even worry about the tools palette. You're not going to be using it. So the two palettes you'll be using will be controls palette and, of course, functions palette. So this is the environment of LabVIEW. Very simple environment, straightforward. Now, how do you create a system? So the easiest system that we are going to create, that is also in the tutorial, is you have a switch and you want to turn on and off a light. It's a simple, very simple system. So how do you find a switch? Again, go to the controls. Express has everything. And if you don't know where it is, then search for a switch. But if you go to Express, you will see different libraries, number controls, buttons, text control, user controls, numeric indicators, LEDs, graph, and text indices. So under buttons, you have different type of buttons or switches. So you have rocker switch, horizontal, vertical, slide switch, horizontal, vertical, toggle switch, horizontal, vertical. So all these switches are there, and you can use whichever OK button, cancel button, stop button. If you're programming and you have a button that you press and it takes your input, OK, and then it starts executing, then you have OK button over here. You have a cancel button to cancel anything, stop button to stop the execution of something. The one that we're going to be using is one of the toggle switch, one of the slide switch, whichever you want to use. So let's say we use up-down sort toggle switch, which is the most commonly used switch in our household as well. And when you put that, you will see that it says Boolean over here. Now, what does Boolean mean? Who can tell me?
Is that referring to just 1 or 0 response?
Exactly. So the Boolean refers to the data type associated with this switch, which means that this switch is going to give you either on and off or 1 or 0. So that's the data type of this switch. You can also go and see in the block diagram that as soon as you put this switch, there's an associated block that is going to appear in the block diagram. And that's the diagram for this switch. And in the block diagram, you can see at the bottom, you have TF for this block, which stands for true and false. That tells you the data type of this switch is either true or false. It's a Boolean type switch. You can change the designation, the name of any block. So let's say if I want to call this my switch, oh, not my which, but my switch. And you can also change fonts. You can change color. You can do anything. Let's say if I want to increase the font size to 24, and I want to make it, I want to make it bold. I want to change the color. So you can do pretty much whatever you want. You can change the font, agency, whatever. So all the control that you have, like in Microsoft Word file, you have all those control, all that control here as well. It is very important for you when you are working on different problems in the homework. It is very important for you because remember, the program is used for presentation of your system to your audience. So it's important for you to present your system properly and explain it properly. For example, if this is a system that I'm designing for my client, then I can say, let's say this is exercise 1, right? So exercise 1, and I will put a brief description as this exercise will turn on and off an LED from a switch. That's what. So it is important that you can do multiple exercises in the same VI file, unless you are using while statement, and I will discuss with you when we discuss while statement. But as I say, you can increase the size of the switch and everything, so you can make it bigger. So it's still going to be switch, but it's going to be bigger. So you can do multiple exercises in one VI file, and you can submit just one VI file, or you can do individual exercises and submit 3 or 4 VI files based upon how many exercises are there. But make sure whatever you're doing, make sure to label each exercise properly, and write down what is the purpose of that exercise. That is, what is the purpose of that control system that you are creating under that exercise. So if it is my exercise 1, I'm just going to write this. This exercise will turn on and off an LED from a switch. That's about it. So this is my switch. Now, where are the LEDs? LEDs are going to be, again, if I go to the Express folder, and I'm going to go to the LEDs. Then I have a round LED, I have a square LED. Let's say I've grabbed a square LED. And since I expanded the size of my I'm going to expand the size of my LED as well. And again, you can see Boolean, which means that LED is either going to turn on and off, of course. So I'm going to call it my LED, let's say. And I can also change the font and do whatever I've been showing you, so it doesn't really matter to me. Now, you can only connect components that interpret the same type of data. For example, both LED and the switch, they can interpret only Boolean type of data. And you can connect them together. But let's say if the switch is a Boolean type and another block can interpret decimal type of data, not Boolean, you cannot directly connect those two components. If you try to connect them, then the wire that you're using to connect them, you're going to see that wire is going to break in the middle. In this case, and again, let's go back. And in the block diagram, you don't have to explain the system, but at least put down that this is, let's say, exercise 1, especially if you're putting all the exercises in one VI file. So you can separate those by exercise 1, 2, 3, 4. In this case, both are true, false. Both are Boolean, my switch and my LED. Both are Boolean types. So all you need to do is when you take your mouse and observe, there are 2 arrows. One arrow is on the right side of this block, and the arrow is on the left side of the block. If the arrow is on the right side, that represents that the data is coming out from that side. And if the arrow is on the left side, that means this block is taking the data into it. So one is sending the data, the other is receiving the data. So my switch is sending the data because you're turning the switch on and off. And my LED is taking that data and turning on and off my light. That's all. And they're connected without any issue because both are Boolean, both can manipulate Boolean type of data. Once you connect them, your system is ready. Now, if you create a system and there's some problem in the system that it cannot work, then your run button is going to have a break in the middle, that it's not going to allow you to run the program. Which means that you have some issue in your system, something is connected that should not be connected, or you put a block and you did not connect it, but you left just the block over there. So it's going to break this run button. It's going to put a line in between. And that means that you have to go back and check your system as what's going on, why you cannot execute your program. Right now, there is no problem like that. We can go ahead and execute our program. So we're going to go ahead and I'm going to run it continuously because I want to see if I'm turning on and off, the light is turning on and off. So once I start running continuously and start flipping the switch, you can see the light is going to turn on and off based upon the position of the switch, if it is on or off. So that's a very simple, straightforward program that shows you how to use different components in the control panel, in the front panel, how to use the control palette, and how to simply connect the blocks corresponding to your system that's in the front panel. Now, all the components that you will see, they have different characteristics, and you can change those characteristics. For example, the switch. If you right-click the switch, you will see data operation. You will see the mechanical action. And there are different type of mechanical action that you can associate with a switch. For example, the default is switch when pressed. So when you press it, it's going to switch on and off. The second is switch when released. So if I do choose switch when released and I run it, then it's going to be held in the position until I release it. As long as I keep my mouse button pressed, it's going to be held in the same position. And when I release the mouse button, then it's going to go to the next position. You can have the third one is switch until released. Then you have latch when pressed. You have latch when released. You have latch until released. So all of these mechanical actions you can associate with the switch specifically designed for your system. Likewise, LED. If you go to the properties of the LED, then you can see in LEDs, you can change the color. When it is on, by default, it's light green. And the off color by default is dark green. So you can change it to any color that you want. Yes, yellow is off or black is off. I can change, of course, the label of the LED. We can change it by clicking the name. So LED is pretty straightforward. It's just on and off color. You can change the on and off color. There's really nothing you want to do from the properties. Of course, you can change size of any component by stretching it, as I showed you. So the right-clicking, with the right click, you can explore quite a few options for each component that you're putting.
Professor.
Yeah.
Sorry to interrupt. So it looks like it actually worked.
Okay, good.
For the serial number, am I putting that serial number in for all of these?
Just put it for all of these, and whichever it will accept. The one.
Okay, yeah, because
the one that it wouldn't accept, then it's gonna say, it doesn't.
Yeah, I tried it for all of them, but it didn't accept the serial number.
It will accept for the main program and for some of the boxes, not for all of them.
Like the base one?
The base one it should accept for sure. It's not accepting?
No.
For me, it didn't either, and then I went
Look
on
down.
to the.
So it's not the first option. There's like a different one near the end. Just try one of those. It works and it has everything in it too.
Wait, which one?
I can't remember which one. I just near the bottom there was one. I mean, I forgot what it was called, but it encompasses everything else. I think when you put the code in.
Let me see.
Okay.
Cecile.
Is it the professional development or the full development?
It might have been the full development or professional development. One of those. It'll work on one of them.
Okay. Thank you.
See, that's the software. It's going to give you options. So this is, serial number option. It's going to give you different options that use serial number, use this, use that, use that. You have to choose serial number and then use this. Yeah, when I installed the same version. When I installed it, and I put the serial number for everything, and it accepted for certain items, and then for other items, it did not accept it. So I'm like, okay, whatever. Okay, guys, so this is the first exercise, just to show you the basic functionality. The next thing we are going to do is mathematical functions, how to create mathematical functions, how to evaluate mathematical functions for different type of inputs, and all those things. So let's say exercise 2. If I say, or I should call it example instead of exercise, but it is what it is. Example 2. This exercise is an example of mathematical operation. Let's just write that. Okay, so exercise 2 is an example of mathematical operation or operations rather. So let's say we want to evaluate some mathematical function or something, and you want to do it with LabVIEW so that you can make it interactive, such that on the fly you can change the values, and then you can see corresponding to those values what is the output. So let's take an example. Let's say you want to do, let's say, or I can just write it down instead of typing it. Let's say you want to do a function f of x, y, a function for two variables, x and y. And let's say that function is 2x cosine of 5y plus 5y sine of 3x. Increase the font so everyone can see clearly. So let's say this is your function. You want to create an interactive program, interactive system with two variables input, x and y, such that when you change the values of those variables, then this function is going to be evaluated and it's going to display the result for those x and y values. So how are you going to create that? In LabVIEW. Now, anytime you are implementing a formula, an equation, you have to realize, first of all, what are the input variables and what are the output variables. There can be more than one output variables. There can be more than one input variables. In this case, we have two input variables and one output variable. We want two input variables, of course, are x and y, and the output variable is the value that is associated with this equation. So once you decide that, those are the things that are going to go in the front panel. That is input and output. Now, the logic, remember, is going to go in the block diagram. Okay. So in this case, we need two what we call numeric control boxes where we can control the numbers. And we need one numeric indicator box that can indicate or display the result. So where are those present? They are present, again, under control. And you can go to numeric control under express. It's also present in the modern, but under express, you have numeric control. If you click that, you have multiple blocks available to control the input value. And the simple one I'm going to use is the number control block. And I'm going to grab two of them because I have x and y. So this is my x, and this is my y. I'm going to again increase the font size so everyone can see clearly. This is my x, and this is my. These are my input variables. Now, sometime in the equation, let's say if I do, instead of 3x, I do 3xy. Let's say this is my equation. Sometimes a student gets confused. They should not get confused at this level. But they put another box, xy. But remember, xy is nothing but x times y. So you still have x and y value. And you're just multiplying x and y and multiplying it by 3. But I have seen students creating a third input box, xy. So don't do that. And there's an output fxy, of course. So for the output, you have numeric indicator library. And the numeric indicators, you can see numeric indicator box, progress bar, gradient bar, progress bar vertical, gradient bar vertical. You have meter, you have gauge, you have tank, you have thermometer. All of these can display result. So to display your result, I'm going to choose numeric indicator. And this is going to display my fx comma y. I'm going to make a little bit modification here as well to show you. some other stuff. So let's say this is my x square, 2x square cosine 5y, and I put a multiplication sign so everyone know that what it is. And I can also put, let's say, 5y cube. So I'll show you functionality of how to take the square, how to do the power 3 and all those things. So let's say 2x square 5 cosine 5y plus 5y cube sine 3xy. So this is basically your function, let's say. And let me go ahead and copy this because I don't want to switch back and forth. This is my exercise 2. And I'm doing this function for my exercise 2. All right, now how are you going to design this function? I'm going to show you how to design this function with individual blocks, multiplication, division, powers block, and all those, cosine block, sine block. And then I'm going to show you how to use in LabVIEW. There are 2 specific blocks. One is called formula block, and one is called, I believe, equation editor. So you can use formula block and equation editor both and create any equation using those. But first, I'm going to show you how to use individual block to implement this thing. Because sometimes you might have to use individual blocks instead of formula block and or equation editor. So when you're implementing this equation using individual blocks, you have to again look at the function and you have to decide what operations you are carrying out for x and y in the equation. So there are 2 parts of the equation, of course. You have the first part and the second part, and both are added together. So let's go ahead and implement the first part first. 2x squared cosine times cosine of 5y. So first you are taking the square of x. Now square of x again is going to be function block. And if you go to either the mathematics library or the express library, go to arithmetic and comparison block library, and then you go to math formulas, let's say, or numeric. Let's go to numeric first. So a square you can find right over here, a square. And again, if you don't know where something is located, you can always search for it. So right here, you have a square block. So if I grab this square block and put it here and connect it, then the output of this block is going to be x squared. So this x squared. I have to multiply that. Oh, actually, I'm going to come back to multiplication. Cosine 5y. Cosine 5y means I have to multiply the output y by 5 and then take the cosine of that. Now, when you are multiplying by any constant value or you are dividing by any constant value or whatever, you have a numerical constant block in the same library. So you take the numerical constant block, assign the value 5, and multiply it by the output y. So you go and grab a multiplication block from the same library. I'm using the same library for everything right now. Arithmetic and comparison, express numeric. So I'm going to grab a multiplication block. And I'm going to put 5, and I'm going to put y. So output of this block is going to be 5y. And you can just double click your mouse, and it's a good idea to write down, okay, 5y is coming out here. Just write down 5y. Write down x squared is coming out here. Also, it might be a good idea to show the label of each block. So if you do the right click and go to the visible items and label, then it's going to show you what this block is, basically. So if you're presenting again your system, although when you're presenting your system to an audience, you're not going to show the logic. They're not interested in the logic. But if I'm doing it for you to understand, or if you are doing something to make me understand, if you're using a block that we have not discussed, then it's good to label the item so that I know which block exactly you're using. So let's say multiplication, which is simple multiplication. I don't have to label it. So now I want to take 5y and take the cosine of that. So the cosine function, let's go back. and cosine function is going to be under, let's see, mathematics and trigonometric function. So you have sine, cosine, tangent, secant, cosecant, cotangent. All these functions are here. So I'm going to go ahead and grab the cosine block, put it here, and connect to the output of 5y. So the output of this is cosine 5y. So I have x squared, I have cosine 5y. I'm going to multiply it by 2, and then I'm going to take the product. So to take the product, first I'm going to show you. Of course, I already showed you that you have the product, but if you're multiplying different items, then you can have numeric. You can have again multiplication block. This, and then I can put a constant with 2. So that's going to be 2x squared. Of course, irrespective in which order I'm putting the input, multiplication block. Multiplication is a commutative process. So 2x squared or x squared times 2 is going to be the same. And then I can put another multiplication block. Take the output of this and the output of this. And the output of this multiplication block is going to be 2x squared cosine of 5. So that's the first part of my equation. So far I'm using individual blocks to do everything. This is my first part of my equation. I still have to implement the second part, and then I'm going to add them together, and that is going to be my output. If any questions so far, anyone? It's pretty straightforward. Let's implement the second part of the equation, 5y cubed sine 3xy. Okay, so we have to implement first y cubed. We have to implement 3xy, then take the sine of that, and then multiply all three of them, basically 5 times y cubed times sine 3xy. So the first thing we're going to do is to take y cubed. Y is already here, right? So I'm going to go ahead and take the cube of that y. Now where the cube is located or any power is located. So you have, of course, a square block over here. You have the power of 2 over here. But in this library, you don't have any other power that you can take. To take any power, you have to go back to math library. And under exponential, there's a function x to the power y. This is what you can use to take any power of any base. X is the base, y is the power. So if I grab this block, and let's say I put it here. Now it is very important for you. So I'm going to do the visible item. It is very important for you to understand there are 2 inputs and 1 output. Now, which input is connected to what? The top input, when you take your mouse, is going to show you y. That is, this is the power. And the bottom input is going to show you x. This is the base. So sometimes students connect in the opposite way. They connect x on top and y at the bottom. So be very careful if you are using a new block and it has multiple inputs. Be very careful which input is connected where. So for this block, power is connected on top and base is connected at the bottom. So base is y. This is my base. So I'm going to connect my base right here. I'm going to tap the wire. And my power is 3 because I'm taking y cubed. So to power 3, I'm going to go back. And I'm going to grab a constant 3 and connect it there and assign it a value 3. So the output of this is going to be y cubed. Y cubed. So that's my y cubed right here. Next is sine 3xy. So I'm multiplying x, y, and 3, and then calculating the sine of that. Now I'm going to show you another block, which is this compound arithmetic block that you can use if you're adding multiple numbers or multiplying multiple numbers. Then you can just use one block instead of multiple blocks like I did earlier. I used one multiplication here, then one multiplication here, because we were multiplying three things together. But irrespective of how many things you're multiplying or how many things you're adding, you can use one block compound and then put all the inputs in that block. And the output is going to be either sum of all those inputs or multiplication, or it can also perform the Boolean operations, AND gate, and other things. So 5y cubed sine 3xy. So 3xy I have to do first. So I'm going to take this compound arithmetic block. By default, it has only two inputs. So if you want three inputs, you're going to expand this. And what I'm going to do, I already have a 3 block over here, so I'm not going to use another 3 block. So what I'm going to do, I'm going to bring this here. And by default, it's an addition in the addition mode. And again, this block, I'm going to put the label. This is the compound arithmetic block. And right now it is in the addition mode. So I'm going to go ahead and change the mode to multiplication. You can do addition, multiplication, AND operation, or XOR operation. So these are 3 Boolean operations, and the first 2 are the mathematical operations. So I'm going to change this to the multiplication mode because I want to multiply the inputs. And then I'm going to do 3xy. So I'm going to take my y. I'm going to take one of the inputs. How many inputs did I do? 3 or 4? 3. Okay. So I'm going to do one input and I'm going to tap y. I'm going to do another input. Let's say middle one. And I'm going to tap 3. Come on. Here. And then I'm going to take the top input and I'm going to put it in X. So let's say if I route it, I'm going to route it like this. So this is my X coming into my compound arithmetic, 3 and Y. So the output is going to be 3xy. Not very clean connection, but it works. Plus, remember, the connection is just for you. It's not for the audience. The audience is just this block right now. But if you can, keep the connections clean. But as long as you're putting that the output of this is 3xy, should be okay. So now you have 3xy. You have y cube. Y cube is coming out of here. And then you have to multiply that by 5. So once again, what I'm going to do, I'm going to take another compound arithmetic block, expand it. Oh, come on, expand. Okay, and change it to multiplication. And I'm going to put, what do I have? A 5. Although I have a 5 over here, if I run this 5, it's just going to become a little confusing. So I'm just going to put another 5. So I'm going to put a 5. Connect it. And then I'm going to put the output of my this compound arithmetic, which is, sorry, I have to put this into sine right now. This is only 3xy, so I have to put it in the sine. So let me go ahead and grab the sine function. And trigonometric and sine. I'm going to connect this to this sine. Make sure you do not connect this to this y, otherwise it's going to be incorrect. And then the output of this is going to be sine 3xy, which is going to go in one of the inputs. And my final input is y cube, and my y cube is right over here. Become a little confusing because there are just so many wires. Where is the best way? Let's see. Let me take it out on the top. Let's say I start here. That's better. Okay. So this is my y cube. This is my sine 3xy. And of course, this is my 5. So all three are going into the multiplication block, and output will be 5 times y cubed times 3xy. And the output of this is 2x squared cosine 5y. This is 5y cubed sine 3xy. This is the output of this compound arithmetic block. So I'm going to take these two outputs and add them together. So let's go back and go to numeric, put an addition right here. I'm going to take this, and I'm going to take the output of this. Add them together, and the output is going to go in the numeric indicator. So this is using individual blocks. This is how I'm going to implement this equation. Complicated a little bit, of course, in regular programming languages. You can just write one line and you can make this work. Even in LabVIEW, when you use formula block that I'm going to show you, it's just one line in the formula block, and that's going to make it work. But again, sometime if you do have to use individual blocks, then this is how you're going to use. You have to dissect each part of the equation and basically program it. But this circuit is, and then the circuit, now this system is done. And if we go back, of course, you're going to make sure you save it. I'm not saving it right now. But once you save it and run it, then you can change X and Y on the fly, and you will see that it is going to change the value according to the equation. You can run the other program as well. So this is equation evaluation or mathematical operation using LabVIEW, using individual blocks. That's how you do it. Any question that you may have? I don't think we need to take break because I'm going to show you formula evaluation, and pretty much that's all we have to cover today. And then I can just go over exercises, and then we can just adjourn our class meeting. If you have any question, please feel free to ask me. So for next week assignment, as I said, you can do all exercises in a single VI file, as I'm showing you. Just make sure you just have label for each exercise, brief description what exercise is going to do, and again separate them by labels. That's all you have to do, and put all the exercises in the same VI file. Save the file as your first name underscore last name underscore LabVIEW homework 1, and that's all. If you prefer to submit individual exercises, then again you have to use one VI file for each exercise and submit them. But it is easier for me to check all the exercises in a single VI file, and it is easier for you to design all the exercises in a single VI file. Sometime, as I said, it is wise to use a separate VI file, especially if you have while condition in your program that you do not know when it is going to be met, as we are going to discuss next week, basically, or week after that. For those exercises, it is wise to use a separate file for those programs that you are creating. But for all the exercises that you're doing this week, a single file should work perfectly fine. All right, the other thing I want to show you is how to use formula block. Instead of using individual blocks, let's say, oh, one more thing before I forget. Cosine function, sine function, tangent, all the trigonometric functions in LabVIEW, the phase, angle, argument, whatever you want to call them, that must be always in radians. Your argument cannot be in degrees for any trigonometric function in LabVIEW. If in your exercise it is given that this must be in degrees, then when you are evaluating the trigonometric function for that angle, you must convert that from degrees to radian before you evaluate it. Otherwise, it is going to be incorrect. So cosine 5y, we are assuming 5y, and that's a correct assumption in engineering. Anytime you are dealing with trigonometric functions in engineering, it is always assumed that the argument is in radians, unless it is specified. If it is specified that it's in degrees or part of the argument is in degrees, then that will be considered in degrees. If it is not specified, you always assume that the angle or phase or argument, whatever you want to call them, that's always in radians. So LabVIEW, the argument is always in radians for any trigonometric function. If it has to be in degrees, when you are evaluating it, that those degrees must be converted into radians. Anybody remember how to convert degrees into radians and radian into degrees?
Yeah, I think it's like, was it like pi over 180, something like that? When you're doing the math?
Yeah. So if you're going from, let me go to, this is easier to do. If you are, okay. So if you are going from radian to degrees, if your angle is in radian, then you're going into degrees, not 0 degrees, into degrees, let's say. Then let's say x is your phase. So x times 180 by pi. If x is in radians, then you have to multiply that by 180 by pi to convert into degrees. And if you're going to degrees to radians, then you go opposite of that. If x is in degrees, then you're going to multiply by pi and divide by 180. So let's say if the argument is given in degrees in LabVIEW, a variable, let's say that this is in degrees, then when you are evaluating that using sine function or cosine function, then before you put the x in sine, so you have x is here, and then you're connecting it to the sine block. Before you do that, you're going to convert this into, you're going to multiply this by pi, divide by 180, and then it's going to go into the sine block, because it has to be in radians before you put it in the sine block. There's also a function available in LabVIEW, built-in function that converts degrees into radians and vice versa. I have not used it, but I have seen a student using it, but you can search. Let's see, search radians, radians to degrees right here, radians to degrees. So there's a function available in mathematics numeric is scaling radian to degrees and degrees to radian. These functions are available in LabVIEW already. So just be careful again that before you evaluate any trigonometric function, it must be converted into radians, because LabVIEW is only going to evaluate the angle in radians. If you put degrees, it's going to assume those degrees are in radians and give you the incorrect answer, basically. All right, let's now show you the, let me just copy this. So let's say this exercise is exercise 3, and this exercise is an example of mathematical operations using formula block. All right, so what we did, we created a complicated system right here with individual blocks, but let's say we don't want to do this, and we just want to use a calculator to calculate everything. So how are you going to do that? I'm going to go ahead and I'm going to grab, let's see if I can grab this, copy and paste. So I'm going to grab, let's see, where did it do? I think this is, instead of putting it again, I just copied it and pasted it. So I'm looking for, this is the third one. Okay, here you go. So this is my exercise 3. Exercise 3. You can always copy and paste blocks and stuff here as well. So I have, again, x and y, and I have fxy. So this is my x. It's calling x2 because it's the second entity. I copied it. This is my x. This is my y. And again, this is my fxy. And I want to implement the same formula, but without going into all the crazy individual blocks. So what I'm going to do, I'm going to go back, get out of mathematics, go to Express, and go to arithmetic and comparison, and go to the formula block right here under arithmetic and comparison. And when I put the formula block, it's going to open this calculator in front of you. In this calculator, you can write any formula. So you can write an equation up to 8 variables, x1 through x8. And you can change the label of those variables. So let's say x1 is my x, and x2 is my y. So I can use x and y now instead of x1 and x2. And now I can put my formula, which is, what was my formula? Let me close this. And so let me move up a little bit. Okay, so this is my formula. X and y. And then I'm going to write my formula. Now my formula is 2x squared, so 2 times x. Now in LabVIEW, the power sign is 2 asterisk, which is the same as in Python. Actually, Python is a language. It uses 2 asterisks. So for power, you use 2 asterisks, or you can press this button. 2x squared times cosine of 5 times y. Observe this green button. If this green button is gray, that means your formula is incomplete. If it is green, that means that part can be executed. Plus, right now, see, invalid formula because I don't have anything after plus. 5 times y cube. 5 times y cube times sine 3xy times sine 3 times x times y. Now, once again, if y, for example, or x, for example, is in degrees, then you can just convert that within the formula, x times pi by 180 or y times 180 by pi, whatever. But it has to be in radians, basically. So you can just convert it over here. Multiply that by pi divided by 180 if x is in degrees, let's say. So this formula is what we are looking for, equation, sorry. This equation is what we are looking for. It is green. That means it's good to go. I'm going to hit OK. And you can also, instead of formula, you can just put here, cancel. You can double click it, and then you can just write down, this is my fx comma y to show this is my formula block for fxy. It's not important. And now you have two inputs, x and y. So I'm going to connect x to x and my y to y. This is because I changed the label of x1 and x2 to x and y. If I don't, then these two inputs will be called x1 and x2. And my result is the output fxy, which is going to go in my output block. So as simple as that. Let's go ahead and run this. And let's confirm if our values are correct. Let's change this to 3. And let's change this to 3. And observe we are getting the same result when we did the individual blocks and when we did the formula block. Change this to 8, change this to 8, negative 62.97 for both of them. You can expand this to see the complete range. Let's see.
Could you show the formula again?
Yeah. So formula is right here. 2x squared cosine 5y plus 5y cubed sine 3xy.
In the
formula block? Yeah. So you double click it and it's going to open that.
Okay. All right. For some reason, it's not letting me press OK.
Okay, you can share your screen with me.
I have it on a different computer.
Okay.
Do it on my PC, but I don't know.
Very hard for me to say. Let me pin it. It's saying invalid formula. Something is not written correctly. Let me pin it.
Okay.
So show me the screen again.
Okay.
2x squared times cosine y plus 5y cubed 3x. Oh, your label. You need to change the label to x and y. x1 to x and x2 to y.
Okay.
Yeah.
X1. Okay.
Got it? Yep.
Yeah.
All right, guys. So this is pretty much what we are doing today. Let's go back to our LabVIEW, and then let's see. So we discussed palettes. You don't have to do exercise 1. I believe your exercises are, let's go and check what are your exercises. Where's my, did I close that? LabVIEW.
Set 3 to 6 and then quadratic equation solver.
3 to 6 and quadratic equation. Okay. So we discussed all this. So you don't have to do 2. I'm just going to start at 3. So this is an example of just addition of 2 numbers, which is simple. We already did the formula or equation. Function evaluation, we did a function, which is not this function, but it's more than this. 2 inputs and output. So exercise 3, you are designing a system to implement this equation. 4x cubed plus 3y squared 7xy. Again, I discussed with you everything, so it's just a different function, but the approach that you're gonna take is going to be the same. You're gonna design 4x cubed for 3y squared. Do not use the formula block for this one yet. Use the individual blocks to get some more practice. Exercise 4, you are creating a system in which you are going to convert temperature given in Celsius into Fahrenheit. The formula is this: temperature in Fahrenheit is equal to 9/5 temperature in Celsius plus 32. Now, in this case, you are using a knob to enter the temperature in Celsius, and you're using a thermometer to observe the temperature in Fahrenheit. And you are going from 0 degrees Celsius to 100 degrees Celsius, freezing point to the boiling point. So remember the knob, as I showed you, the knob is in the numeric indicators. Let's go back. So the knob is, thermometer is in numeric indicators, which is what you're going to use to represent the temperature in Fahrenheit. And make sure you have to adjust the range. To adjust the range of any knob or thermometer, you just have to click on the number. So if you click on the number and let's say 0 degrees Celsius is 32 degrees Fahrenheit, freezing point. So you just put 32, it's going to adjust the range from 32 to 100. And likewise, you're going to change the upper range from 100 degree or 100 to the boiling point in Fahrenheit, which is, anyone know what is the boiling point in Fahrenheit?
212.
212. So you're going to change the range just by clicking so that you can see the complete range of the conversion from Celsius to Fahrenheit. And to enter the temperature in Celsius, you're just going to use a knob right here. And again, you're going to change the range from 0 degrees, 0 is already there, to 100 degrees Celsius, so that you can cover the whole range. So this will be your Celsius, temperature in Celsius, change the label to temperature in Celsius and change the label of thermometer to, let's say, temperature in Fahrenheit. And then just implement that formula, 9/5 times temperature in Celsius plus 32. And the output is going to be temperature in Fahrenheit. Exercise 5, design a control to find voltage across resistor R2 from the following circuit. Okay, so LabVIEW is not a circuit simulator. But in this case, you're not doing simulation of a circuit. All you are doing is you are implementing this formula to calculate the voltage across R2 right here. To calculate the voltage across R2, we use voltage division. If the resistors are connected in series with the battery, then we can apply the voltage division formula to calculate the voltage across R2 or calculate the voltage across R1. And the formula, as you can see, is given here. The voltage across R2 is R2 over R1 plus R2 divided times the source voltage. So I created this, these lines and these boxes using the library decoration. So there's a decoration library in which you can have decoration items, lines and boxes. So that's how I created this, just to show that this is a circuit. And then this is a knob, of course. And these are numeric controls. And this is numeric indicator. And then I basically implemented the formula. Another way to do that is, might be easier way to do that is just go ahead and just cut this thing. And then in LabVIEW, here, let's say this is the exercise. So you go ahead and paste this thing, right? And then you can use the knob over here. Instead of this, you can just put a knob over here. And you can use numeric indicators over here, R1 and R2. So you can kind of modify this and remove this VS part and replace it with a knob right over here. But first remove the part, let's say. And this is good, actually. You don't have to remove it. It can come on top of it. So this is going to be your VS. And likewise, you can put numeric control. One box here for R1, one box here for R2. And then you have a numeric indicator to show the voltage across R2 that you can put right over here, basically, VR2. So that's another way to do that. I think I like that way because it actually looks like a circuit, clear circuit, and you don't have to use decoration or anything. So you can do this. That's perfectly fun. Just make sure you don't have knob 2 written over here. Just you can delete it or put VS or whatever. And likewise, this is R1, so you can just delete that because R1 is right here anyways. And likewise, you can delete that. R2 is right there. But anyways, whichever way. So all you're doing, remember, those things are just for decoration purpose. The lines and everything. So then there's no functionality of these lines or these boxes. So if you have the circuit already with you, then you can just use the circuit and then insert your controls in that circuit or on that picture, right? There is a circuit picture maybe. You can insert your controls on the picture. Remember, again, the purpose of this is to represent your system. The best way you can represent your system to the audience, that's how you have to do that. So I would rather do it like this because it looks like a circuit. And it's easier to do, as you can see. So again, there's the same thing. You're implementing this formula to calculate the voltage across R2. Once you change the source voltage and you change the resistance values, then voltage across R2 is measured using this equation. If you do have to use pretty much similar what I'm doing, then just go to the modern and decoration library, and you can draw lines and everything from there. Okay, this now quadratic equation solver is solved in your tutorial. You don't have to solve it yourself. I mean, I would like you to solve it without looking at the diagram, but it is already solved. So basically, you are solving for the roots of a quadratic equation, ax squared plus bx plus c. And to calculate the roots of a quadratic equation, everyone should know that quadratic formula is given by negative b plus minus b squared minus 4ac, square root of that divided by 2a. One root is positive, minus b, negative b plus, one root is negative, negative b minus. So this is root 1 and root 2. And this is my front panel. And I'm implementing these two formulas based on the values of a, b, and c. So I went ahead, and this is also something that is given that you should look into that as how to create a help file for your system. So you can just read it. I don't have to go over it, but just read it, how to create a help file for your system. And it's going to show you, or not help file, description of your system, rather. I would say that, not help file, but description of your system, documentation of your system. It is given over here. I'm not going to go over it, just read it. It's pretty straightforward. Going back to the solver. So this is, with individual blocks, this is how I created the system. And it's going to calculate root 1 and root 2. So you have b square minus 4ac is coming here. I take the square root of that. And then I have the negative sign over here. So I'm going to add these two for the first root. I'm going to subtract that for the second root. And then I'm going to divide that by 2a. And again, you can implement. You don't have to look at this. You know the formula, and you can implement this. Now, this is only going to give you real roots, because you know that quadratic equation can give you either real roots or complex conjugate roots based upon the values of a, b, and c. This one is only going to give you real roots. You have to create this program to consider both roots, real and complex conjugates. So the question is how you can find the complex roots as well. And it is very easy. All you have to do, of course, is to create the program like this problem, this block diagram. Once I have this block diagram, identify which component produces complex values. In the formula, which component produces complex values? What do you think? Anyone?
This part, the discriminant, the square on the square root.
Square root, yeah. The square root, whatever is written under the square root, if that value is negative, that's going to be a complex value. So in LabVIEW, the square function, let me go to LabVIEW and show you that actually. In LabVIEW, if I pull a square function, let's see, where is the square root? Increment, multiply, divide, infinity, and square root right here. This is my square root. If you want this square root to handle both real and complex values, you have to right click it. And then you have to go to, where is it? Properties. And under properties, output configuration. And then representation, the default is double floating point, basically, decimal. Click on the double and choose complex double, which make this square function handle complex quantities. So that's all you have to do if you want to see, if you want to evaluate real and complex both values. So make sure you convert this to complex double. Adapt to source. And then OK. And likewise, since you don't have to do the adapt to source. I don't think I did that. You can try it, but you still have to choose complex double for the square root. But you also have to display that complex number. So once again, to display the complex number, when you have your numeric indicator, you're going to right click, go to data operation, and no, not data operation, go to the representation, and then choose complex double for the indicator as well. Because if you don't, then that will not be able to display the complex number. It will only display the real number. And if there's a complex number, it's just going to show you not a number. It cannot represent a number. So this is what you have to do in order for this program to display both real and complex roots. That is, change the data type, change the representation of the square root to complex double, and also change root 1 and root 2 representation to complex double. That's all you have to do. And this is given over here, basically what you have to do. Representation complex double. So make sure you do that, because this is one of the problem from your homework, one of the problems from your homework. Although it is solved, but I do want you to work on that to get some more practice and submit it along with your homework. But it is a solved problem, remember. So usually if there's a mistake in this problem, I usually take more points off, because again, it's already solved in the tutorial. So this is an example, two examples, or one example rather, that it's going to display the complex values 2 to 3. All right, I think the last exercise is this exercise. This is again formula block, how to use the formula block. And again, warning is make sure not to use formula block unless it is advised you to do so. Now, you're not using any formula block, by the way, for this homework, but you can use it for different exercises in the future. But in this homework, I don't, any exercise before formula block, you're not using formula block. And this exercise, which is the last exercise, exercise 6, there's no use of using formula block for this exercise, but this is a very simple exercise. So in this exercise, you are converting a binary number to a decimal number. Binary number is given as an input through 3 switches, and the decimal number is displayed in the numeric indicator. So these 3 switches are representing numbers from 0, 0, 0 through 1, 1, 1. So all the combinations of zeros and 1 are entered through these switches. If the switch is off, it is 0. If the switch is on, it is 1. I change the color of the switch, right click, go to the switch, change the color, such that when it is on, it will be red, and when it is off, it will be gray. You can do that as well. If you don't do it, that's fine with me, doesn't really matter. But again, you have to present it in front of an audience, so it just looks good to show different colors when it is on and off. And the equivalent number is displayed here. So observe right now I have 0, 1, 1. 0 this is called most significant bit, which is the leftmost bit. And this is called the least significant bit, which is the rightmost bit of a digital number. So 0, 1, 1 in decimal is 3. It's going to go from 0, 0, 0, 0 is 0, and 1, 1, 1 is 7. So total 8 numbers can be displayed with 3 bits from 0 through 7. 0, 1, 1 is 3. Now let me ask you this: how many of you know, or let me ask you this: how many of you don't know how to convert binary into decimal? Is there anyone who does not know how to convert binary into decimal? I'm assuming everyone should know. Everyone, I'm assuming, might be taking IET or might already have taken IET, Introduction to Engineering Technology. And I think we do convert binary into decimal in IET. If you don't know, that's okay. You can just do a small Google search, how to convert binary into decimal, and it's going to show you how to do that. So you are implementing the formula to convert binary into decimal. Now each bit is going to be converted into its equivalent decimal value. And then you're going to add all the decimal values to represent the final number. A word of caution though. Remember, these switches are Boolean, true and false. And this is a decimal. So you cannot directly connect switches to the decimal. You cannot apply the logic and then connect it to the decimal. So the first thing that you're going to do is to convert the Boolean format of the switches into decimal format. How are you going to do that? It is right here. You will need to convert the Boolean logic of switches into equivalent 0, 1 decimal 0, 1. How do you do that? Go to this palette, Boolean palette, and there's a block Boolean to 0, 1. And that is the block you are going to use. You're going to connect after your switch, and the output of this block is going to convert the Boolean coming from the switch into 0 and 1 in decimal. And then you're going to apply the logic to convert that bit into the equivalent decimal value. So make sure you do that. If you're not going to do that, it's not going to let you connect. It's not going to let you create the logic from the Boolean switches into decimal. So go to the Boolean palette. Boolean palette is in the function block. If I go to search and Boolean, so you have Boolean to 0, 1 right here. The first one that came up is Boolean to 0, 1, which is under the Boolean palette. a Boolean library rather. I'm calling it palette, but mathematics, numeric conversion, and it's also under Boolean, but it's given here as well. Again, I did a search. Let's see, let me go to the Boolean. That should also be there. Express, let me see if it's in the Boolean or not. Arithmetic and comparison, Boolean, and no, it's not in this library. So it's in the other library that I was showing you under mathematics. Mathematics, numeric, elementary, linear algebra, different. Where was it? I forgot. Numeric, no, not in numeric. I forgot where it is, but as I said, I can always search it. Boolean, express Boolean, Boolean to 0, 1. So that's what you're going to use Boolean to 0, 1 right here. Input is going to be Boolean function, output is going to be decimal output. And then you're going to apply the logic to convert the Boolean number into the decimal number. So these are 4 exercises or 5 exercises. How many? 3, 4, 5, 6, and quadratic equation, 5 exercises. So these are 5 exercises for next week. And I have explained them, I guess. I hope you understood each exercise, what you are doing. Everything is given in the tutorial as well. Everything is given in the pre-recorded lecture as well. And this lecture is recorded as well, that I'm going to post the link. So if you need to revisit any part of the lecture, you can always revisit. But I think that is about it for today. Any question that you may have, I'll be glad to answer that question.
I have an unrelated question.
Is everyone here? 1, 2, 3, 4, 5, 6, 7, 8. So everyone is here. I think we have 8 students and all 8 of you are here. So if there is no question, we're gonna go ahead. Let me go ahead and stop recording.